Welcome to Module 5, Part 1. Please note, I misnamed Modules 7 and 8 several times in this video. I should have referred to Module 7 as the endospore stain and Module 8 as the acid-fast stain.
Hello. Welcome to the video that will cover Module 5, Simple Staining. Before I go any further, I just want to inform you that I have posted a slideshow that covers staining and staining theory on Canvas. You'll be able to find it quite easily. Please watch that slideshow before you watch the rest of this video. It will help you understand what's going on much more clearly. Okay, so let's provide a little bit of background here. In Module 4's video, I talked about the necessity of staining bacteria so as to be able to see them clearly. I pointed out in Module 4 that bacteria, most bacteria, do not have color. They are colorless, they are transparent, they are incredibly small, and therefore they're almost impossible to see without some sort of staining protocol. So what we have to do to make them more easy to see is to give them color. And that's what stains are doing. Staining protocols are techniques designed to give color to the bacterium or to structures that are part of the bacterium. Now, in order to do this, of course, you have to use chemicals that have color, and those chemicals are referred to as dyes. In order to use the dyes, we have to dissolve them in a solvent. The combination of dye dissolved in a solvent is what we call a staining solution. I have an example right here. This is a staining solution we're going to be using for Module 5. This is methylene blue staining solution. This is made by taking methylene blue, a dye, in powder form, and dissolving that methylene blue powder in some sort of solvent to produce a methylene blue staining solution. Now, as my slideshow points out, dyes can be broken into two groups, basic dyes and acidic dyes. Basic dyes will directly stain or give color to the bacteria. Acidic dyes do not give color directly to the bacteria. Instead, acidic dyes will stick to the glass slide and not stick to the bacteria. All the staining protocols that we are going to do in this will use basic dyes like methylene blue. Now, staining protocols can be broken up into or categorized into four categories. Simple stains, which use only one dye, one staining solution. Differential stains, which will use two or more dyes and allow us to tell the difference among the bacteria that we've stained simply based on the differences in color. The Gram stain and the acid-fast stain are both examples of differential stains. Third category of stains would be structural stains. These are staining protocols that are designed to impart color to specific bacterial structures. For example, there's the flagella stain that will give color to bacterial flagella. There's a capsule stain. Many bacteria have capsules that surround them. That's a structure. The capsule stain gives color to the capsule if it's there. Cell wall stain. Cell wall stain uses a dye that imparts color to the bacterial structure called the cell wall. Those are all examples of structural stains. The fourth category of stains is called reserve material stains. Now, we need to understand that bacteria are just like all living organisms. They will, if possible, they will store nutrients inside of themselves for future use. Bacteria can store excess phosphate inside of themselves. Some bacteria can store excess fats or excess lipids inside of themselves. When that happens, the excess phosphate that is being stored is a type of reserve material. The bacterium is keeping the phosphate in reserve. Same thing is true for the lipids and fats. Bacteria that can store excess lipids and fats inside of themselves to be used at a later date, those fats and lipids that are being stored inside the bacterial cell are a type of reserve material. The materials are being reserved for use at a later date. Now, there are a number of stains that have been designed to stain reserve materials, to stain phosphate, to stain lipids and fats. I'm not going to say more about those stains because we aren't going to do any of those stains in this class. The stains that we are doing in this class in modules 5, 6, 7, and 8 belong to the first three categories. Simple stain, which is module 5, differential stains, modules 6 and 7, which would be the gram stain and the acid-fast stain, and then module 8, which is an endospore stain, which is a type of structural stain. But let's move into the material covered by Lab Module 5. Lab Module 5 instructs us in how to do a simple stain. By definition, a simple stain is a stain that uses only one dye. We're going to be using methylene blue staining solution. Methylene blue, as I mentioned a few minutes ago, is a basic dye, which means it will, the methylene blue, the colored part of methylene blue, will stick to the bacterial cells themselves. This will give the cells a blue color. Methylene blue will not stick to the glass slide. So after exposing the bacteria to the methylene blue and giving the methylene blue a chance to stick to the bacterial cells, we then merely have to wash off the excess methylene blue, and all that methylene blue will wash off the slide except for the methylene blue that is sticking to the bacterial cells and making the bacteria blue. Now, whenever you do a bacterial stain of the sort that we're doing here in modules 5, 6, 7, and 8, you need to start with a properly prepared bacterial smear. I showed you how to do a bacterial smear in the video that goes along with module 4. So I made the decision to prepare the bacterial smears for today's lab prior to turning on the video camera. So these two slides, this is E. coli, this is a smear of Cucuria rhizophila. These two slides have smears that have already been prepared. They've been air dried and heat fixed and they're ready to go. So in order to do the staining protocol, I take the two slides, I put them on the rod that is sitting across this staining dish rack, and I take my methylene blue staining solution and I cover entirely the smear on each slide. I'm going to leave this staining solution on the smear for at least 60 seconds. Now you can go a little bit over and it doesn't hurt, but the target time is 60 seconds. So I'm not going to make you sit here and watch me, so we'll stop the video and come back after 60 seconds. Okay, 60 seconds have elapsed. So now it's time to take each of these slides and wash the staining solution off the top surface of the slide and the bottom surface of the slide. I shake the excess water off and I grab the other slide and I wash the methylene blue staining solution off the upper surface and off the bottom surface. I want to be sure that it's all been washed off, and then I shake the excess water off. Now we're not quite done yet. We have to dry the slides first. And so I take a piece of folded paper towel and I'll take each slide, one last shake to get rid of the excess water, and then I will fold the towel over the slide and blot it dry. Do not rub, just blot. Okay, that slide's done. I take this one again, shake off the excess water, use the paper towel to blot the slide dry. I usually do 2 different locations in the paper towel to make sure that I get all the water off. And that slide is done. Now, a couple things I want to note. Before I started this video, I washed my hands and I disinfected the lab bench before I started. Second thing that's important to know is that you need to properly dispose of this used up staining solution that is sitting at the bottom of the staining dish. We have a special bucket that is designated for this sort of waste. So when I'm done shooting this video, I'm going to empty the staining dish into that staining bucket. Then of course I'll wash out the dish. Finally, you'll notice that when I handle the slides, I handle them barehanded. Usually when people do staining, they will either use gloves, which I had them sitting here and I didn't put them on. Go figure. Or they'll use, as your lab manual suggests, they'll use spring-loaded clothespins, or they'll use little slide holders that are specially designed to pick up the slides and put them down. You just use whatever works best. Again, I normally don't do staining without gloves, primarily because I don't want to get the stain on my fingers. But if you were working in the lab, you might have the option of either using gloves or using some sort of slide holder to move the slides around. So that's it. The next step, of course, would be to take these slides and examine them under the microscope using the oil immersion lens. And I'm going to show you that in just a moment. So this part of the Module 5 video showed you how to actually do the stain. The next part of the Module 5 video will show me focusing the oil immersion lens onto these stain smears.